SoWrong. It talks about doing perfectly normal things that you do every day at work, at home, and so on, in absurd ways. So, which makes you think while doing it, this is so wrong, right? Okay, let's go ahead. So, why do you want to do these things? We already know how to do certain things, and that knowledge is so deeply embedded in us that we sometimes fail to recognize certain parts of the concept or the problem. But by doing them in strange ways, maybe we can learn something new about about the thing that we were doing, right? Let's take a real life example. Tell someone that they owe you 819 rupees, right? It's a fairly common scenario, although the number is not that common, right? Uh, Usually someone will use splitwise, or they'll just text you that, bro, or that that time we went out in the restaurant for dinner, we had to split up the bill, and then this is what you owe. But you have to count on your hands, so you can't write down the number, and you basically uh, okay, for argument's sake, let's say you can only text them, or actually WhatsApp them, pictures of your hands. Right now, how do you tell them the amount that they owe? And you can't point to the number written down somewhere else. You can't write the number on your palm and then send a photo of that. No, just for argument's sake, let's say you have to count in your hands. Now, the biggest you can count on your hands seems to be the number 10. And then if you start counting the little lines uh, of the little lines within your fingers, maybe you can get to like something like 32 or something like that. But 819, that's a really big number, right? So how do you do this? Maybe you can just forget about it. Right? But if you really think for a minute, you could do something like this, right? Where every extended finger is 1 and a closed finger is 0. And then what ends up happening is that suddenly you realize that while you were using your fingers as symbols, as in the first finger represents 0, the second finger represents 1, and so on, you could have done what you could have done is represent them as positions, and the open close represents the symbol. Then suddenly you go from being able to count till 10, 20, or 30 to being able to count up to 1024 just on your hands, right? And then this becomes 819. So that little constraint, that not being able to write down numbers, teaches us something about numbers. uh, the Romans never got very far because in counting, the Romans never got very far in counting because those numbers had some positional elements in it, but not completely. And then these Indo-Arabic numbers that we currently use uh, lets us count basically up to any number we want because of the positions, right? So that's the gist of what we are trying to do here. By introducing ridiculous constraints, try and understand what it is. Uh, what is it that we do on a daily basis? So, web frameworks. Ever since the internet was invented, the default interface has been web frameworks for most of the things around the world. Uh, Earlier, you used to write things for a certain desktop. That's not the case anymore. You just write a website for it, right? Or basically with all these other things in the game. The okay. So the point being, web frameworks, the standard way to do this is you write a function, you decorate it with something, or you could write a fancy class, and each method in that class represents something. Like you can do a define get inside the class, and then so on. uh, but what if you can't use classes and functions? Is there can you still write APIs? um, Mind you, different APIs, so you should be able, your server has to serve maybe the home page and maybe some other thing. uh, can you still do this? And without further ado, we can. It's a ridiculous way of doing it. We use a for loop, right? This is just the gist of the code. We will get into the code soon. So for request and response in get that URL, response.body has to be high, right? Fairly simple way of doing it. So how does this work? Let's dip into some code now. So we have a little thing. Now of course I said no functions, but since async can only be written inside async, so let's just wrap it up inside a function called application. So request response in get home body is this: request response get hello world, and robot. That's a body, right? So now let's run the server, and then call localhost 8080 robot, and you get the robot back. What if you do hello? You get hello back, right? Okay, so let's make this interesting. Can our server run both of them at the same time? So can you do something like while true, do this, while true, do curl http hello, done. So it turns out we can actually serve both of them at the same time. So yeah, that's how it is. That ridiculous piece of code actually works. Okay, moving on to the next shocking thing. When you're writing a web server, if you have some sort of state involved, eventually everything becomes SQL, some or the other form. The top one is from the Django ORM, and the usual approach is you introduce some sort of ORM, object relation mapper. Like Django has its own thing. You can use PV, you can use SQL Alchemy, and lots of other things. What they do is they'll define classes for tables, and then they use some meta classes and all those things to introduce custom things, that custom methods that you can do with those classes. The other way, which I actually prefer, is you directly embed SQL into your Python code. Because the reason I prefer it is because if you're using an ORM and you're not using something like back references, end of the day you're just writing SQL disguised like Python. So just write SQL then, right? So but now the constraint. So you can't use classes, and you can't use strings. So can you still write SQL or some altered form of SQL in Python? Just think about it for a second. Can anyone come up with something? You, sir. You seem to have a pensive look on your face. Okay. Yeah. So the thing I came up with was something like this. It's It's a hack, and I'm not proud of this, but turns out you can do it. And basically the so the thing to note is that in these examples, create, table, user, name, text, age, real, none of this is defined. Not in some global state, not in some local something fancy. No, you just type out what you need, right? And it works. Surprisingly, it works. Um, Even the last one, right? Select star from user. It works. Now, this is good enough. So let's get into the code. So here's what we've written. We have three things, right? Create table user, name, age, real, values Arjun 600. Oh, I'm not 600 years old. Let's give it a nice number. What's the like the ideal age? Let's say 28. Let's say that, right? Or maybe some ridiculously, like I'm Yoda or something, 1,000 years old, right? What the run function does is it takes your function, your SQL, and then runs it, right? So when you actually run it, this is what you get. So the first thing we ran created this SQL for us, create table username, and it returned nothing, right? And then select star from user, return nothing. Insert into this, and then select star, it returns something. So we can see it's running, it's valid, it's somehow able to get these things to run, right? You can take a look at the code later on. Okay, so now we've done two things. Now stalling APIs are bad. The usual knowledge is that inside an API you don't do long running stuff. You offload to another process, and Celery is like a big thing that you runs in the background. You transport your stuff to that, and then and so on. So how do you do this? The ridiculous constraint here would be you have to remain in the same process. So let me talk about the problem a little bit. So for example, you have some simple server, right, which does some big task. The big task being, say, n for I in range int n sleeps 0.1, right? So let's say that's your API, and then so what you can do is do, let's say, 10 of this. So while that is happening, notice that you can't actually do anything else. So let's say you do 100, and then curl http localhost 8080 and then sum. It doesn't happen. You have to wait for the first guy to finish, and then it comes back to you, right? That's the state we're in now. So ideally you would pump this off to Celery and then have something come back in the thing. Now the constraint is that you have to stay in the same process. You cannot change the way the person who's calling you calls you. You can, however, change like certain things. You can make a get, a post, or something like that. And trivial changes that you can do, but you can't have them call 5 APIs instead of 1, right? So how do you do this? So basically your normal thing, x do big task X has to turn into something like this, right? uh, Turns into something like this, and then the caller just uh, sets the maximum redirects to infinite. Like, just redirect me as many times as you want. So when you look at it, uh, so this is your code, right? And then you do something like diff big task and for I in range int n, sleep 0.1 yield, right? Maybe yield I or something, I don't know. So now what happens is that your server, when you ask it to do 100, instead of making it a single API call, uh, it happens recursively. And the nice part is that while you're doing this, you can have other requests mixed in, obviously with some delay, right? So this little trick lets you do basically whatever you want, right? uh, so those are the examples. Now what do we learn? uh, Clear thoughts lead to exposed faults. In this case, what is a web request? Do you want to be able to alter the core logic somehow, independent of the core logic? For example, logging, you want to log requests, you want sessions on that, and so on. So expressing it as a loop does not do justice, because a loop cannot be referred to. It's too simple of a thing, right? Maybe you can introduce something later on, but then uh, the loop, you can't refer to a loop, and then you can't do an early exit in a loop, since there is no concept of a early exit. Yeah, you can do a break, but yeah, I guess you could do a break. Yeah, maybe I'll change the slides a little bit. Okay, so but you can't decorate a loop. You can't do something like @login required, like Django does, uh, to a loop. And then there's also the obvious performance hit. To get this hack to work, your server basically slows down a lot. Okay, things that are forced will break down faster rather than things that are natural, right? You're trying to write SQL and you're trying to use the Python syntax to do it. So while these little things are okay, the last one actually starts showing a little bit of wear and tear. So you can't use the actual from, because that's a keyword in Python, and if you do that you get some syntax errors. Let's just jump back into, this is the breakdown code. Select column names from table. So frm is here. So when I run this, right, I can't do it. I have to do something like this. Right. So for example, from, I can't do that, because Python's parser will say that if it's a from, you need either an import or something like that. There's knowledge baked into keywords, so you can't do that. This is only because you're forcing it. You could use a string, which is, I think, the obvious way to do it, right? A good solution really solves all cases, not special ones. this batch yield thing that we did, notice that if during the step of the big task, you can't actually do anything else, and the only reason it works is that if that step is small enough, someone else can connect and have their request served in the middle of it. So you cannot truly serve someone else